Hi, welcome to this video. In today's video, I'm going to do a very interesting problem of Turkish Mathematical Olympiad of 1996. The question: prove this product as k goes from 0 to n minus 1, 2 to the n minus 2 to the k is divisible by n factorial for all positive integers n. Okay, go ahead, pause this video and give it a try to this problem. When you're ready, keep watching to see how to solve this problem. Okay, let's get into the solution now. If you take a look at this product, you see I have 2 to the n, which is even number. Okay, so I'm going to find out the relationship between n factorial and 2 to the n. Okay, as you know, the n factorial is a component of odd numbers and even numbers. Okay, so we are able to extract all even numbers from the n factorial. Okay, so we can rewrite this n factorial on the form of 2n, okay, as an exponent. As you know, n factorial is written on this form: n multiplied by n minus 1, okay, multiplied by n minus 2, and so on and so forth, all the way down until you get the last term. Okay, inside of the n factorial there is a large amount of number 2. Okay, we are going to extract all number 2 from this factorial to figure out how many number 2 we have, how many number 4, how many number 8, how many number 16, how many number 32, how many number 64, and so on. Okay, so these numbers, it will be written on the form of 2 to the n, okay, as an exponent. This is our goal. This is the relationship I can build between n factorial and this product. Okay, so in order to do that, I'm going to use Lejeune theorem. Okay, for example, n2, a multiple of 2, so n over 4 multiple of 4, to extract all number 2 from this factorial, as you see here. So number n factorial is written on this form, okay, by using the Lejeune theorem. Is written on this form: n over 2 n plus the floor of n 2 to the 3, because it's 2 to the 3 is 8, and so on and all the way down. Okay, this one I can rewrite it on this form, as we have this sum of the floor of n 2 to the n, as n goes from 0 to infinity. Okay, so this is equal n factorial. Okay, multiply by another product. Okay, let's call it p to the q, for example, as q goes from 0 to the n, for example. What I did here, I'm just extracting the even number from this factorial. Okay, multiply by the rest. Okay, because we don't know the rest. This strictly inferior than 2, the sum of n over 2 to the n. Okay, as n goes from 0 to infinity, because we have the floor, because this floor is strictly inferior than sum of n over 2 to the n, as n goes from 0 to infinity. Okay, because we have floor is always strictly inferior than because we have fraction. Okay, if we have integer, then we become strictly inferior or equal, okay, to this number. So now what I'm trying to do now, if you take a look at here, 2 is divide n factorial, because this product is multiple of 2. Okay, so I can rewrite it on the other form as well. So this one equal to what? As you know, also this sum 1 over 2 to the n, as n going from 0 to infinity, equal to 1, because geometry series, this one is written on the form of 1 over 2 plus 1 over 4. This here is written on the form of 1 over 2 plus 1 over 2 to the 2 plus 1 over 2 to the 3, and so on until you get the last term, which is 1 over 2 to the n, which is equal to 1, because it is written on the form of classic geometry series. Okay, So this n factorial is strictly inferior than 2 to the sum of n over 2 to the n, as n goes from 0 to infinity, okay, multiplied by another product, let's call it q, as q goes from 0 to the n. This one equal to 2 to the n, okay, multiplied by this product. As you see here, now this term is a multiple of 2, okay, so I can pull out number 2 from here. So 2 equal to multiply by 2 to n minus 1 multiplied by this product. This one implies 2 divide n factorial, okay. Now on the other hand, we have this product. This product is written on this form: 2 to the n minus 2 to the 0 multiplied by 2 to the n minus 2 to the 1, and all the way down until you get the last term, 2 to the n minus 2 to the n minus 1, okay. What I'm trying to do now, so this product, this one equal to 2 multiplied by 1, 2 to the 2, 2 to the 3, and all the way down until we get the last term, all the way down to the n minus 1, factor 2n minus 1, factor 2n minus 1 minus 1, 2n minus 2, 2 to the n minus 2 minus 1, and all the way down. So now this product equal to 1 plus 2 plus 3, and all the way down until you get the last term, 2n minus 1, okay, multiply by this one, let's call it capital A, okay, this one. In the same time, this one, this is nice formula arithmetic expression, so this one is giving me n to the n minus 1 over 2, okay, multiplied by capital A. I put this whole thing as a capital A, okay. So if you take a look again, you see number 2 as an exponent, it shows up here in the first term as a product. So now I'm going to take number 2 from here. So this product 2 to the n minus 2 to the k, as k goes from 0 to the n minus 1, okay, equal, so I have this product 2 to the n minus 2 to the k, as k goes from 0 to the n minus 1, equal to this one. I'm going to pull up number 2 from here, 2 to n minus 1 over 2, okay. If I'm taking number 2 from here, so I put minus 1, okay, multiply by capital A. If you distribute, this one is giving you 2, n minus 2, multiply by n minus 1 over 2, multiply by capital A, okay. So now what is this? So now I have this one equal to this one, that's mean 2. This one is telling us 2 is divide this product 2 to the n minus 2 to the k, as k goes from 0 to the n minus 1, okay. Now we proved 2 divide n factorial, and we proved 2 divide this product. This implies n factorial divide this product to the n minus 2 to the k, as k goes from 0 to the n minus 1, okay. It's called transitivity divisibility type property, okay. I have done with this problem. Thank you for watching. I will see you in next video. Bye.